Welcome to part 2 of TEK A.4A. If you recall, in part 1 we had just finished solving this problem here, find the area and the perimeter of this composite figure. So now we're going to move on to this following example. Here we got x squared minus 3x minus 10 is modeled with tiles as shown below. So these are using what we call algebra tiles. Algebra tiles are represented by different size pieces. They have different values. The large squares are worth x squared, and the long rods are worth the value of x, and the small squares are worth a unit, or 1. And so I want you to notice this right here. If you laid it right here, that rod would be the same length as that side of x squared. So if you lay another one this direction, that rod would be the same length this way as well, because this is a square, right? And so that's why this has a value of x squared, because if you think about how you find the area of a square, you multiply each side together. X times x makes x squared. Okay, that's going to be important when we go to work this problem. The only difference between the clear and the shaded is the clear are positive values, and the shaded are your negative values. Okay, so over here, it says, what are the factors of this trinomial? So we are trying to factor this trinomial meaning 3 terms, into 2 binomials. Okay, so we got two term factors. All right, and so we can use this model, which represents this trinomial, to easily factor this problem. Okay, so first I want you to see how this models what we have up here. The big square again is x squared. All right, these longs each have a value of x. And these each have a value of negative x. We're going to see how when you put all this together, you get the original trinomial that we started with. And each of these guys, if I can fit in here, each have a value of negative 1. Again, this is just based on what the key told us. This is the value of each of these blocks. Okay, so if you combine these, look at how you get x squared minus 3x minus 10. Here's my 1x squared right here. The minus 3x comes from combining the 2 positive x's with the 5 negative x's. Okay, so negative 5 plus 2, it makes negative 3. And then the minus 10 simply comes from having 10 of these little shaded blocks. So those are minus 10. Now the key to doing this with algebra tiles is when you're given a trinomial that you're trying to factor, you have to come up with a shape that forms a rectangle. Okay, so you always start with your x squared pieces first. So this was just 1x squared, so I just need 1x squared piece. Always start with that first, and then off to the bottom right hand corner of your x squared pieces, that's where you're always going to build your unit pieces, so always do that second. Okay, so x squared pieces go down first. If you have more than one, just lay them next to each other side by side. And then in the bottom right corner, wherever your last x squared piece is, that's where you're going to form your unit pieces, the minus 10 in this example. Once you've laid those two things out, then it's just a matter of filling in with the x's, trying to figure out whether you need positive or negative x's to create that middle term. Okay, so if you have algebra tiles at home, this is real fun to kind of practice and get used to doing. You can also draw it on paper like they did here, or you can print out a colored sheet off Google Images and then just cut them out to make your own tiles. But practicing making these rectangles will help you if you're not real comfortable with how to do factoring using the algorithm. Now, to figure out what these two factors are, all you got to do is figure out the length and the width of your rectangle, because the length and the width of your rectangle, when multiplied together, make this, right? So let's start over here with this side. Now, I told you earlier that the x squared piece is formed by an x multiplied by an x. So this side, on this side here, would be equal to 1x, because that's how long that piece is. And then if you notice, each of these rods on this side of the rod here is the same size as our unit pieces. Okay, but because these are shaded, this is going to be equal to negative 1, negative 1, negative 1, negative 1, and negative 1. So this would have a grand total of 1, 2, 3, 4, 5. So you got a grand total of negative 5. So this side over here of the rectangle is x minus 5. Now we can do the same thing across the top here. Again, the x squared has a length of x. You go down it. And over here, since these are white, these are actually going to have lengths of positive 1. So when I combine those, we get a total of positive 2. So the top part has a dimension of x plus 2, and the side is x minus 5. So guess what? My trinomial factors into two binomials of x plus 2 and x minus 5. See how simple that was? So you can do this with any trinomial that you're trying to factor if it's factorable. You will run occasionally into a trinomial that cannot be created into a rectangle. And when that happens, it just means it does not have, that one's not factorable using our ways that we normally would do. Okay, so again, start with the x squared pieces, then in the bottom right hand corner, build your unit pieces, and then fill in with rods for your x pieces to make a combination that will form the middle term. So some will have to be positive, sometimes they're both positive, sometimes they're both negative. In this example, we had some positive on top and some negative on the bottom to create that negative 3x. You just kind of got to play with it until you get the right combination. Okay? Alright. This is our last example for this TEK A.4A, which says you should be able to find specific values of a function. So here's our function, f of x equals 3x squared plus 10. We want to find the functional values indicated below. Okay, so f of x, that's the name of our function. Here when we see f of 2, that means we're asking to use 2 as our input into our function. Here's our function rule, we're going to put 2 in there, and we need to come up with what the output is. Okay, so we're going to have 3 times 2 squared plus 10. Notice I put the input in parentheses. That will save you from making mistakes when you're dealing with negative inputs down here, like with negative 5, if you put it in the parentheses, especially if you're trying to use a calculator to help you solve these. It will prevent you from making a mistake on the calculator. So here we use Pemdas, or order of operations. So we're going to start with the exponent, 2 squared gives us 4. And then we do multiplication next, which gives us 12. And then finally we use addition, which gives us 22. So 22 will be the output when the input is 2. Okay, so let's try another one. Here we got an input of 4. So the only thing we're changing is our input value. Everything else is, the rule is going to stay the same. The order of operations doesn't change, so you're still going to do your exponent first. Still going to do multiplication second. And we're still going to do addition last. Alright, so our next input, so for that one the output came out to be 58. I'm sorry, my handwriting's a little rough there. Output is 58 when the input is 4. So our next one we're going to do an input of negative 5. So here's where that parentheses that I was talking about earlier is really going to come into play, especially if you're doing this on a calculator. Okay, so our input's negative 5. Notice I'm putting it here in the parentheses. I'll explain why here in just a minute. Okay, remember how I said order of operations is key here, right? So if you don't include that parentheses, if you just put negative 5 squared, one of two things may happen. You may misinterpret the problem to think that this really says 3 minus 5 squared, and try to do the subtraction first before you square it. Or the other possibility is you may punch it in the calculator as just negative 5 with the square on it and no parentheses. And out here to the side, I'll show you what happens. If you punch this in the calculator as just a negative 5 with the square on it, and that's all you type with no parentheses around it, the calculator uses order of operations just like we do. So it says I need to do the exponent first, and then I need to put the negative sign on it. So I'll do 5 squared is 25. then I place the negative on it, and I get a result of negative 25 out of the calculator. However, we know that the input is what's being squared, so it's supposed to be negative 5 that's being squared, not just the 5. So this is wrong. We don't want that. We want to do negative 5 times negative 5, which is positive 25, whenever it works out the exponent. Okay, so parentheses are crucial when doing these kinds of problems, when you're filling in inputs to find outputs. Then we go back to our multiplication, 3 times 25. And finally, our addition. So when the input's negative 5, the output is 85. Okay? All right, last one. So for this one, our input is negative 5, 6. Also, just like the last one, crucial that you put it in parentheses if you're using a calculator to help you do this, or you will get the wrong result in the end. Which is sometimes why doing it by hand is better than doing it by calculator, because you're a little less likely to make the same mistake doing it by hand. Alright, so again, using Pemdas, we start with the exponent. So this is really saying negative 5, 6 times negative 5, 6. If that's not something you know to do in your head, just work it out to the side. You know your rules for fractions. If you're multiplying two fractions together, oops, that's supposed to be a time symbol. Two fractions together, you multiply straight across, meaning numerator times numerator, denominator times denominator. Okay. So negative 5 times negative 5 is 25. And 6 times 6 is 36. So this would have a value of 2536. Now, if that could be reduced, you'd want to reduce it. In this example, that cannot be reduced, so we're just going to leave it as that fraction. Alright, so next is going to be multiplication again. So now you're doing a whole number times a fraction. Now, I've taught you guys that there are a couple ways you can do this. You can make this 3 over 1 and do it just like what we just did a second ago. Or you can really just think of this as 3 times 25 divided by 36. Okay, 3 times 25 divided by 36. Alright, if either way, you're going to get the same result. Okay, I know for some people it's easier for them to see it as a fraction times a fraction. And one benefit of seeing it as a fraction times a fraction is you might see that you can actually reduce this before you multiply. Because 3 and 36 can reduce. And when you multiply two fractions together, if you can reduce either numerator with the denominator, you're allowed to go ahead and do that before you multiply. So again, that makes the math a little easier. Now it's just 1 times 25 and 1 times 12, because we're multiplying straight across, and you get 25 over 12. Now, at this point, I would be fine with you converting it to decimal if you chose to. You probably need to look at, if this were a multiple choice problem on a test, what are my answer choices written in? Are they written in decimals, or are they written in fraction form? If they're written in fraction form, then you're better off to stay as a fraction than you are to change it to decimal. If they're written in decimal form, go ahead and change it to decimal. Now, in order to add these two here, the 10 and the 25 12s, so if I'm going to leave as a fraction, I'm going to have to put 10 over 1 and get my common denominator. Common denominator for 1 and 12, 12. So we're going to end up with 25 over 12. And then I'm going to multiply the top and the bottom by 12 over here. So it's going to be 120 over 12. Okay, so now we're simply going to add the numerators, right? Because we're adding fractions, so we just add the numerators together. I'm going to come back down here so it's kind of out of room. And 25 plus 120 is 145. Now again, depending on what your final answer is, you may just be able to leave it as that. You may be able to reduce it. This one in particular does not reduce, but you may have to reduce your fraction. You could change it to a mixed number. Whatever the final answer is in, that's what you want to change it to. Okay, but 145 12 would be fine for the output for this one. All right, so this concludes part 2 of TEK A.4A. Thank you for your time.